Hello everybody, I'm Nick, and in this video I'm going to introduce you to the weirdest but also in my opinion the best feature of C# 11, and that is static abstract members in interfaces. Now this is actually a C# 10 feature, but it is only a preview feature in that version. So it is coming as a fully fledged feature in C# 11, and because I've been doing some digging, I saw that the .NET team has been using it literally everywhere. It's all over the BCL. It enhances a lot of stuff that we are already using, and I can't wait for it to be out fully because I have a lot of use cases. So let's see what it is, how it works, and how you can use it as well. If you like that type of content and you want to see more, make sure you subscribe, ring the notification bell, and for more training, check out chapsas.com. Now, just a small thing before I move on, I want to let you know that I bundled up all of my courses with a slight discount in my website, chapsas.com, so you can check that bundle if you want to buy all of my courses. And I also bundled up my 2 testing courses, my unit testing in C# and integration testing in C#. You can check that too. They're bundled up, they're discounted, so they are in the description down below if you want to buy them. Okay, let's go straight into the code now. All right, so let's see the problem that the feature is actually trying to solve, right? So I'm gonna go in this project over here, and this is a .NET 6 project. It doesn't use any special features. This is just C# 10 .NET 6. Now, I'm intentionally using the example that Matt Storgensen is also using to demo the feature. I'm going to try to explain it in a bit more developer-friendly way, and then I'm going to show you how you can use this practically in your own code. So I have the add_all method, which accepts an array, and then that's an array of integers, and we're iterating over the array, and we're adding all the integers together, and then we're returning that result back. It's pretty straightforward. Now, this works great. However, if you wanted to, let's say, have the same method over here, but instead of sum for integers, you want to have a sum for doubles. So you also added a double over here. Well, as you can see, this doesn't really compile anymore because it says the argument type is double, but the method accepts an integer array. And that's fair. Now, the problem we have is that we cannot simply turn this into a generic method over here and have a T type which you can accept for a few reasons. Firstly, there is no concept of 0 when T isn't, let's say, a number, and we can't simply say here where T is a number or an I number. So there is no such concept in .NET 6. And even if there was, we would need to access static members of that generic type, which if it's based on an interface, it just doesn't have. So what we would have to do if I just revert all those changes is simply make a second method which works with doubles. So double here, double there, and add all D, and now I can deal with this. However, that feature, static abstract members and interfaces, will actually allow me to turn this into a method that works with a generic. Let's see how. I'm going to close that and go into this project, which is using .NET 7. And I'm also going to enable preview features because at this stage, it's still technically in preview. Now I have the same method, but like I said before, I want to turn this into a generic method over here. And this is how I would do it, but I need a constraint. Now in .NET 7, the .NET team has actually changed the BCL to have a few new interfaces. And now I can have a constraint on this T to be an I number of T. An I number has a lot of interesting members in it. For example, if I go in here, it implements a bunch of other stuff, but also it has these static abstract members. What is that? These are methods. I can call these methods statically if I want to. If I go deeper into I number base, I can see that I have even more interfaces here, and they have even static properties. So 1, the concept of 1 can be represented as a static abstract property of T self. The concept of 0, I can even go deeper through these interfaces and have addition operator overload. So I can overload the plus operator and change that behavior. And that then allows me to just say statically T dot 0 because the concept of 0 exists, and simply set the language version to preview. This will change my CS proj over here. So if I just show you, it adds this line over here. And this now compiles because both the plus operator is overloaded statically through that interface, and 0 exists. So if I go into this, you can see it takes me in this operator overload, which means that for whatever type implements iNumber, when you implement it, you have to specify what 0 means, what plus is supposed to do, what minus is supposed to do, what 1 is supposed to do. You set those constraints, and then those constraints can be used through that interface statically, which allows you to do generic math in this specific example, meaning that if I was to add a double into this array and turn this into a double array, this still compiles, because now it's a double, but double, if I go into double, also implements binary floating point, iNumber, and then from iNumber you have all the same stuff where you need to implement the 0, you need to implement everything. So when I go into the double, I can search for 0 equals this, and I can see that I'm forced to implement them from the iNumber base over here. So all of that now opens a whole new world of things you can do. And I want to take this a bit practically, because you might be looking into that type of maths and you'll be like, okay, but I'm not doing maths, you know, that's great for .NET and the BCL and everything, so they can clear some things up. But what about me? Well, let's see what is, in my opinion, a very simple example. So I'm gonna go in this API project, and this API project is just a simple minimal API, but because I don't want to just do app.map get hello world and have all of my handlers and all of my logic here, because why would I do that? Minimal doesn't mean that everything needs to be in the program.cs. I can also structure my project in any way I want. What I've done is I've made these endpoint classes which have to implement this endpoint over here. And this endpoint allows me to specify the pattern, which is basically the path for this endpoint, then the HTTP method, get, post, put, delete, whatever, and then the delegate, which is the handler, which basically is how am I supposed to handle this request? Give me the method. So hello world, for example, here looks something like this. And if I go to program.cs, I have made an extension method, map endpoint, which accepts an endpoint, and it just calls the pattern, method, and handler, and this just works. If I go here and I run this and I bring Postman in, then if I call this endpoint, you see hello 29-year-old, and this can change to anything. Here we go. So this is how this API works. However, my biggest complaint with this is that I have to instantiate this endpoint class for no reason. Like, why do I make an instance? Oh, I make an instance because I have to, because I want to access these properties. And if this was just a generic method, so if it was like this, and I went into the map endpoint method, I would have to change this quite a bit. First, I would have to say t over here, and then I would have to have a constraint, so where t is endpoint. And even if I do have that, I don't have a way to access those things because they're not statically accessible. So I'm kind of stuck. And I could technically say endpoint equals new t, but then t needs to have a newable constraint. And what if t has parameters in the constructor and it can be newed up? It's very, very tricky and very, very weird. So what I can do is use static abstract members and interfaces. So I can go into the endpoint, change this to a static abstract, and say you have to implement this, and these will be statically accessible. And I'm going to enable preview for this project, so this now works. And I'm going to go here and say public static for those things, because now they have to be static. And also this will have to be static. And now that's it. I can go to the extension method, and all I have to say is t.pattern, t.method, t.handler. And I no longer have to instantiate anything because it doesn't need to be instantiated. And if I run this again, then I can go ahead and call that endpoint. It still works as you'd expect. So this is a way to practically use this example. And it really doesn't stop there, because you can also mix and match some static members on things that can be instantiated. It's great if you're writing generic methods, especially when you're working with reflection as well. For validation, it will be great. There's so many options with this. And I think Microsoft isn't presenting the feature in the best way possible. They're presenting it in a way that makes sense for them and what they're using it internally, but not really for what me and you would use it in our projects. But I think this way, a way to show that you can actually have metadata for your class, which you can statically access and use in many scenarios, including generic ones, is a better way to think about it. But now I want to ask you, what do you think? Have you used this feature in preview? Is it something that you have a use case for? Would it help your code in some way? Leave a comment down below and let me know. Well, that's all I had for you for this video. Thank you very much for watching. Special thanks to my Patreons for making this possible. If you want to support me as well, you're going to find a link in the description down below. Leave a like if you like this video, subscribe for more content like this and ring the bell as well. And I'll see you in the next video. Keep coding.